All right, so last little bit of notes, and this is the only time I always end on this, because if you got down how to do gram-to-gram conversions, the 3-steppers that you did yesterday, this part is really just 2 problems in one. That's it. So if you can do 2 problems, then you can do limiting reactants. They are. I'll show you how to know when you're dealing with one. So let's actually figure out what's the difference between limiting and excess. So the difference between limiting and excess, I got to tell you what they mean first before I show you the problem, okay? You need to know this. Limiting reagents limits the maximum amount of product to be formed, okay? I know that sounds backwards, but let's put it this way, okay? If you go into the grocery store, let's just assume apples cost $1, okay? No, just $1. 1 apple, $1. Okay, let's just keep it simple, okay? If you have $10, what is the maximum amount of apples you can buy? 10. Why?
Because you only have $10.
You only have $10. Your limiting reagent then is not apples. It's your $10. Does that make sense? It's limiting of how many apples you can buy. Okay? So more money, then you're not going to have so much. So let's say but you only want to buy 10 apples and you have $50. You'll have $40 left over. Then your $40 would be your excess. Okay, so this is a way to kind of look at it. You can only buy so much with what you're doing. Okay, some people want to talk recipes, and yes, that's true. This is one reason why recipes, like when you're making a cake or something like that, deal with certain things. Okay, the limiting basically limits the maximum amount of stuff you can do. Okay, so what I'm trying to tell you is we care about the limiting, we don't care about excess. That's what it comes down to. All right, this is the one not completely consumed, you have leftovers. So, how is this going to look in chemistry? All right, you got the idea that limiting is what we care about. You still need to label your excess, but that's easy to find. We're looking for limiting. He's more important. So here's a reaction. If you want to know how breathing masks work, this is how they work. They work by taking potassium superoxide, reacting it with water, and then it produces oxygen gas. Okay, that's how they're able to breathe. But notice this down here. This is a question you'll get. Okay, what do you know is different from this question than all the others you did yesterday? There's 2 grams instead of 1. You remember when I said there are like 2 problems in one? That's what I mean. You're basically, and I'm going to give you the overview here, then I'm going to go get real specific. The overview is this. You're going to convert this to your products, okay? And then you're going to do a second problem where you're converting this to your products. You're going to compare them. Whichever one is lower is your limiting reagent, okay? So, now here's the thing. Right at the bat, somebody thinks, well, why can't I just look at this and tell who I'm going to run out of first? Some of you are like, well, that'll be what's left over because there's more of it, and this will be...
but it's all a ratio.
That's what's screwed up. First off, you'll notice the mass of water and the mass of this are very much different. Also, your ratio between here and here is different. You got to take all that in consideration. So you cannot just look at this and guess. You do have a 50-50 shot of getting it right, but that's not going to help you. Okay, so read the question very closely. You have 2 things. Think of it as 2 problems in one. Do one conversion at a time. Do not do both at the same time. You're going to confuse yourself. So look at this. Take one problem, convert it to your product. Put it to the side. Then do another problem with this and convert it to your product. Compare them. That's what you're doing. So I'm going to do it all with you here, all right, step by step, okay? So I'm going to do blue for the first guy, green for the second, okay? So potassium superoxide is right here, okay? Then you got 47 grams of water, and that's right here, okay? With me so far, okay? Where are they both going to? Read your question. How many grams of, where's that at? Okay, so what I mean by 2-steppers, or not 2 steps, but 2 different problems. You're going to take your blue, convert it to the red, that's one problem. Okay. You're then going to take your green, convert it to the red, that's your second problem. So I'm going to tell you, when you're doing your mass to mole conversions, these 2 numbers are not going to intersect. If you're putting them in the same problem, you're doing it wrong. Okay, so how some people say do this. This is my advice. Pick one to start with and cover up the other guy. Okay? I'm going to say my green's the second one I'm going to do, and I'm going to say the blue is the first one. Okay? So I'd say cover up one. Okay? Do this first guy. Get him out of the way. Then go back, cover up this guy, and do the second one. That way you're not confusing yourself. Okay? I've seen people do it. All right? Now the question is, you want to convert them both to your same product. Why?
Because they're both exactly.
Well, real reason why is this. You're trying to compare them, and you can't compare them if they're both two different units. You see what I'm saying?
Yes, sir.
If you put this to O2 and then this to O2, you can then compare them both. And because they're not going to be the same number, they're going to be the same unit. And you can figure out which one is more and which one is less. The one that is less is your limiting. And then I'm going to show you how to memorize that. Okay? You're going to get practice today, don't worry.
Less limiting.
So, less limiting. So we're going to take your KO2, put it to your product. Then we're going to do a second problem where we're going to invert this. Okay? So we set up our little thingy. Okay? It's a mass to mass. Cover up this guy. The green, we're not doing green, we're going to do blue. 120 grams of superoxide. That is going to go here. All right? So, first step, looking at your map, if you're lost. You're starting, if the map was up here, you got your mass and you got to go to mole. Okay? What's the conversion ratio for this? You got to find the mass. So, let's say I found it for you. Okay, yeah, you're right. 71.1 grams. All right? What does this equal?
1 mole.
1 mole. Okay? Now, however, some people are like, well, wait a minute. There's 4 moles up here. You're not doing that until here. Okay? So what I mean when I say 1 mole, if you have a gram and you're going to mole, which you will, that's always going to be 1 mole. We want to set it to 1 mole. Some people want to go ahead and put this in there and start plugging things in. Don't do that. A way to memorize this is if they're on top of each other, they need to be equal. If they are not, okay, then you're doing it wrong. That's the best way to check. Okay? So always go back and check. What's on top and bottom? Is it equal? Okay? All right, so what cancels out here? Grams. Why does the gram go on bottom? Okay.
Because it'll cancel out.
That's the, again, important part there. So we're in moles of KO2. We now need to get from KO2 to oxygen.
So KO2 is on the bottom with 4 moles.
All right, so what's your ratio there? 4 to 43. Which one of these two go on bottom? This goes on bottom, then this go on top. Okay?
So the moles cancel out, and then you got your.
So why does the KO2 have to go on bottom? Look what's diagonal. So they cancel out. Again, and in case y'all are, what I said earlier, the only time you're not going to have 1 mole is when you're doing this, the mole to mole conversion. It may both be 1 mole, 1 to 1. Sometimes it is. However, most of the time it's going to be depending on what ratio you have between the two guys. Yeah, y'all are going to have a lot of work to do. So now we're in mole of O2. Okay? Does everybody see that?
Yes.
All right, let me go back through this one more time. Okay? Where do we get the 120 from?
The KO2 is a problem.
120 grams of KO2. We got the 71 grams of KO2 from the mass off your periodic table. You have to add that up. Everything off the periodic table equals 1 mole. The grams has to go on bottom to cancel out. Okay? You're now in moles of KO2. The question says, go from KO2 to grams of O2. Well, you can't go right to grams yet, but you can go from mole to mole. And there's your ratio.
So put the other mole on the bottom of it.
4 mole on bottom, and then the 3 mole would have to go on top. The reason why is to cancel out the KO2. Everything diagonal will cancel out. Are these two equal to each other? Bless you.
No.
Yes, they are. 3 and 4 are not equal numbers, no. But looking at your formula, 4 moles of this will equal this. That's why you balance your ratio. We just don't usually use the equal sign, we use an arrow. So I know it does not look numerically right, but based on your formula, it is. We need to get to grams. So here's the thing. We need to find the mass of this O2. Okay? How do you know that?
16 times 2.
16 times 2. So what does 1 mole weigh of O2? 32. Okay? Why don't we put 3 moles here? Because we already put 3 moles here. You took care of that when you did this. So notice this. What's on top of each other is equal to each other. All you're doing is putting everything equal to each other, but putting them in the right form so they cancel out.
I don't do it all together like that.
You can do it in sets.
Should I do it like that?
To get my answers, yeah.
Okay, I'm
If you do it all at once.
That seems easy.
You'll be closest to mine. But if you're off by a decimal, it's not a big deal. If you're off by whole numbers, then that's a big deal.
What if it's like 1 point?
So do we find that?
1 point. If it's over 1 whole unit, then that's bad. But if you're within a decimal range of what I got, then you're fine.
Okay.
Okay? Always go with the closest on the test. All right, when we do all the math, this is what they did. This times this times this times this, divided by this times this times this.
72.67.
Okay.
Oh, no, brother.
It's like, don't know where you got that number. Okay? All right, so you see how you did one problem, okay? You did this one. Toss it to the side, okay? Now do the second one where you're going to here, okay? So you start up your own separate problem.
47 on top, and then
I would.
Ain't that the same thing?
get your stuff off.
Yeah, I've seen people do them. I want you to do them side by side. I mean, don't do them all, left to right, but do them side by side. Okay. So 1 mole of water weighs 18.02. Notice where we repeated the same pattern. We just used a different different compound. That's about it.
Your 4 mole weight.
All right. So step 1, gram to mole conversion. Step 2, mole to mole. Look at your ratio between these two guys. Now we do our mole ratio. What's the ratio between these two? 2 to 3 or 3 to 2, depending on which way. But which one goes on bottom? The 2. If this 2 goes on bottom, and then this 3 has to go on top. They are equal to each other, but double check to make sure these 2 are diagonal, same unit, so they cancel out. All right? Last step. Go back to grams, but you got a different compound now, so you got to look it up. Good news is, guess what? You'll notice this is going to repeat again. So that's why I like you doing them side by side when you're doing limiting, because you're always going to convert to the same product to compare them. You don't want to compare them to 2 different products, because then you can't compare them. You want apples with apples. So this last step right here is going to repeat down here. Ooh, yikes. So let's take a look at these 2. Notice this. This weighed more to begin with, but it produced a least amount. This one weighed less, but produced more.
It's because of the ratios.
The ratios is what screws it up. So you can't just look at your reactants. Okay? All right, so what are we supposed to say? So go back to your thing here. All right? So, limiting reagents, listen up. Limiting reagents limit the max amount of product to be formed. This reactant will be completely consumed, used up. Excess is what's left over. Okay? Let me put it to you like this. Limiting reagents produce a smaller amount. Excess produced a larger amount. That's the broke down definition of what you need to know numerically wise. Does that make sense? That should be easy to remember because limiting sounds small, or limiting is less, excess is more. Okay? That's easy to remember. So let's look at our answers again.
Is the question going to say which one is your limiting, which one is your excess?
Yes. That is what all of these will ask this. Okay? So which one is smaller out of these 2?
40.51.
Okay? That's your limiting. Now, let me explain this. Limiting reagent or limiting reactant, it is not a product. It is a reactant. Okay? They're asking which of these 2 is the limiting, not these. These are products. You base your answer on the least amount of product. So your answer is not this. Your answer is 120 grams of KO2 because that was your reactant. So be careful. Yes, you do need to do the math, and I see people do this all the time, but then they don't explain which one's the limiting and excess. Okay? It's not the 40.51. That's a product. This is a product too. It's the first guy you started with, or the one in the question. So your answer is going to be one of these 2. You got to find which one. And it's the one that's smaller. We really don't care about the excess, but we do need to label him.
Okay.
Okay? But once we know who's the excess, we don't care about him anymore. Because if I react these, in other words, what it's saying is this. If I react these two guys together, my maximum stuff I'm going to make is this. Because it's based on the limiting reactant. So here's the thing. You notice whenever the previous questions. Okay, let me go back to this one. Notice here, the difference between limiting questions I give you and these is that I've already told you what the excess reagent was.
Oh, that's the thing.
I said an excess hydrochloric acid. We're just saying I got enough of this crap to go for days. Okay, we don't worry about it. But I only have a limited amount of this because that's the only thing I got. So anytime you saw excess, I already gave you the excess. Therefore, by default, that was your limiting. However, what if I said I have 100 grams of this, 100 grams of this? Which one am I going to run out first? That's the difference between the two. So this one actually makes the other guys make sense now. Makes those other questions a little bit more comprehensible. Just it's a little bit extra work, and I didn't want to start y'all off with that. All right, so why do you need to know this? Well, in your lab tomorrow, you're going to have to do something called percent yield. And you're going to find your limiting reagent depending on the max amount of stuff you make. And then you got to basically tell me how much you got right. Okay, you remember when you did hydrates and it should have been 36% water? So you got close to that, and then you were off by a couple little bit percent. You did a percent error, which tells you how much you were off. Percent yields tells you how much close you were. It tells you the other side of the whole thing. Okay? So it's telling you what you got wrong. It's going to tell you how much you got right. And that's the next part that we got to do. Okay? So here's a question. This is a tag-on question. What you've been doing here is getting your theoretical yield. Anytime you do stoichiometry, every single worksheet I've given you, you've been doing a theoretical yield. That's the only thing you've been getting. It's what should happen. So it's like, according to my calculations, as you go do this, this is what I should get. Okay? Exactly. So what you've been doing when you're doing those worksheets is not but theoretical. Okay? In other words, you haven't been really doing lab work. If you go in lab tomorrow and you do this, let's say you did this reaction, but you only got this mass, okay? Then you need to figure out what you got off, because you should have got this.
Yeah.
But you got this.
Yeah.
Okay, let's say you got that. Then that's where the percent yield comes into play. It's easy. Remember, anytime you deal with percent, it's always like part over whole?
Yeah.
Okay, well, there's a formula to it.
100.
Times 100. Same thing here. Your theoretical yield is going to be your whole. It's what you should get. Your actual is going to be what you should have got. I'm sorry, what you got in lab. Okay? Does that make sense? So, an easy way to remember this, because they both sound alike. How I remembered it, and it's very cheesy. This is my definition down here. Actual yield is what you actually got in lab. Okay. So, whenever you got actually, that mass, that's what you actually got. However, when you do stoichiometry, that's what you should be getting. So, guess what? How this relates to part over whole. Part is going to be what you got. Whole, or total, is going to be your theoretical yield, what it should be. And it makes sense. So let's do this problem here. So question, if you only had 35.2 grams of O2 recovered, is that your actual or theoretical? If you only had actual or theoretical, 50-50 shot here.
It's actual.
It's what you actually got, okay? So what's your theoretical? Well, theoretical is always based on limiting. So since this limits your reaction, the maximum products you can make is 40.51 grams.
Wait, so actual is because it says were recovered? Like, as long as that was recovered?
Right. So you should have got this, but you got 35.2. So you're off by something. Okay? So we're basically trying to figure out what your grade is.
Oh.
Okay? So like if you got like 35 questions out of 40 correct, what would be your grade?
You actually did not make an A.
No. Let's see. But you didn't do really bad. Let's find out. So we know this is your actual, that's your theoretical.
So
We're going to need these two values.
theoretical is the one you worked out.
Right. So let's do our formula. Percent yield is just like part over whole times 100. Actual over theoretical.
Actual over theoretical.
Aluminum.
Okay? So the 35.2 is your actual. That will go on top. And then your 40.51 will go on bottom because that was your theoretical.
So 35.2
40.51. Oh, times 100. So this isn't bad because I can actually look and say, well, he's kind of close to 40. He's off by 5, but he's
He's got like an
That's all you gotta do
88.
for this?
yeah, about 80, somewhere in the 80s. So looking at this, the part over whole or the actual over theoretical. Actual is your part where you make mistakes, and then the theoretical is what it should be. That's your target. You're trying to make that. Okay. Some of y'all did get like 0% error. If you get 0% error, you have 100% yield. Does that make sense? If you have 2% error, you have 98% yield. How am I figuring this out? Subtract this from 100.
Is your actual, like, what you're supposed to get your yield.
13.
Yeah.
And then, like, if it all comes out even, then it's all yield.
Kind of. So like, for example, if I'm trying to figure out how much error this guy has, I would subtract 86.89 from 100. That will give me my percent yield. So that's another way of getting 2%. I'm sorry, percent error. Okay? He was this much accurate, but how much did he miss by? It was about 14%.
Oh, okay.